This is M. Sambaraj, Assistant Professor, Institute of Aeronautical Engineering College. Today we are going to start relative speed. Chapter name: Time, Distance and Speed. First subtopic: Basics. Second, relative speed. Third, average speed. Fourth, boat and stream. Fifth, races and games. These are the subtopics in time, distance and speed. Now, we'll start relative speed concept. These all subtopics are depending only one method. Time is equal to distance by speed. This topic particularly find out only relative speed. A concept of the topic: method. Time is equal to distance by speed. Here find out only relative speed. Here time and distance values are given, and find only relative speed. Relative speed concept: if two trains or objects are moving same direction, then relative speed is a difference of their speeds. That is, same direction indicated difference. Similarly, two trains or objects are moving opposite direction, then their relative speed is sum of their speeds. Sum indicate addition, opposite direction addition concept. Relative speed concept examples: if two speeds are given, then check the direction. Same direction minus opposite direction addition. Here next, third point: meeting time. Meeting time is equal to distance by relative speed. Relative speed examples: either calculate meeting time or calculate meeting distance. Meeting type of questions are belongs to relative speed concept. If you read the problem, if two speeds are given, then first example: find the distance from station A where the two trains will meet is dash, or find the distance from station B where the two trains will meet is dash. Number 2, at what time will they meet is dash, either from station A or from station B. Next, third example: when they will meet is dash. This type of questions are important to competitive exams, also campus placements. You may write any placement exam. One question is belongs to only relative speed concept. Next, notations. All the statements are converted into a same units. Units always depending only distance. If distance meter is given, speed convert into a meter per second. Distance kilometer is given, speed convert into a kilometer per hour. And time: if speed meter per second, time convert into a seconds. Speed kilometer per hour, time convert into a hour. These three notations also important to relative speed concept. Next examples. First example: a train leaves the station A towards the station B at an average speed of 60 km per hour at 9 a.m. After 2 hours, another train B leaves the same station and moving same direction at an average speed of 100 km per hour. At what time will the meet is dash? A. 1 p.m. B. 12 p.m. 12 p.m. C. 1:30 p.m. D. 2 p.m. Here find at what time will the meet is dash. Meeting type of questions are belongs to relative speed. A relative speed concept, meeting time is equal to distance by relative speed. Here A speed 60 km per hour and B speed 100 km per hour. These two trains are moving same direction. Then relative speed is equal to difference of their speeds. 100 minus 60, 40 km per hour relative speed. And find distance. Meeting time is equal to distance by relative speed. A relative speed given but distance not given. By using above condition, calculate only distance. But above information, after 2 hours, second train leaves the same station. A train A and train B. The time gap between first train and second train is 2 hours. The time gap between first train and second train is 2 hours. Therefore, 2 hours distance covered by A. A distance is equal to speed into time. A speed 60 km per hour. A time 2, 60 into 120. The distance between A and B 120. The time gap between A and B is 2 hours. We want only distance. The distance between A and B 120 kilometers. Relative speed 40. Meeting time is equal to 120 by 40, 3 hours. After 3 hours they will meet. Find meeting time. Starting 9 o'clock. A and B gap 2 hours. Meeting time of 2 trains 3 hours. 9 2 plus 11. 11 plus 3 14. 14 is called 2 p.m. Option D only correct. Here easy method. This complete topic. All the problems are depending only one method. That is time is equal to distance by speed. Here find out only relative speed. You check the problem. Only 2 points only important. Either same direction or opposite direction. Same direction minus operator. Opposite direction addition operator. Then first example answer 2 p.m. only correct. Next second example number 2. If the distance between two stations A and B is 200 kilometers, train A leaves the station A towards station B at an average speed of 30 km per hour. After 2 hours, another train B leaves the station B towards station A at an average speed of 40 km per hour. Find the distance from station A where the two trains will meet is dash. Option A 60, B 80 kilometers, C 100 kilometers, D 120 kilometers. First method general procedure. Second method shortcut method. First general procedure. Here the distance between two stations A and B is 200 kilometers. But after 2 hours, second train leaves the station B. These two trains are moving opposite direction. But first train takes the time gap between first train and second train is 2 hours. That is, first train takes 2 hours more than second train. Then 2 hours distance covered by A. 2 hours distance covered by A. Distance is equal to speed into time. A speed 30 km per hour, time 2 is equal to 60 kilometers. A total distance 200. A only covers 60. Remaining distance is equal to 200 minus 60, 140 kilometers. In 140 kilometers, find meeting time. Time is equal to distance by relative speed. A distance is equal to 140. Opposite direction relative speed plus a 140 by 72 hours. After 2 hours they will meet. A meeting time 2 hours. Again 2 hours distance covered by A. A D2 is equal to S into T. A 30 into 2 60. 60 kilometers. A total distance covered by A up to meeting point. D is equal to D1 plus D2. 60 plus 60 is equal to 120 kilometers. This is general procedure. A next shortcut method. If the question is belongs to opposite direction, if the problem is belongs to opposite direction, just calculate only. Suppose this point is called meeting point of two trains. A total distance 200. Here A distance up to meeting point plus B distance up to meeting point is equal to 200. A distance up to meeting point plus B distance up to meeting point is equal to 200. Suppose consider A meeting time up to meeting point x hours, then B time up to meeting point x minus 2. This is only important. Here A time up to meeting point x hours, then B time, here B time is 2 hours less than A time, less than indicate minus operator x minus 2. A distance speed into time 30 into x. A B distance speed into time, here B time x minus 2 is equal to 200. A next 70x is equal to 280. X is equal to 4 hours. Meeting time x is equal to 4 hours. Here calculate only A distance. A distance is equal to 30 into x. 30 into x 120 kilometers. Option D only correct. This is about second example. A first one general method, second one shortcut method. By using shortcut method, A time consider x, B time always exist only x minus only applicable but not x plus, because a total time duration x, remaining x minus only applicable. You check only the time gap between A and B. A time gap between A and B is 2 hours. Therefore, B time x minus 2. A procedure, only one statement. If the problem is belongs to opposite direction, just to apply the method. A distance up to meeting point plus B distance up to meeting point is equal to total distance. A total distance is equal to 200. Here calculate x, where x is called A time up to meeting point. Here calculate A distance up to meeting point 30 into x 120 kilometers. Similarly, find the B distance up to meeting point. A B distance up to meeting point 40 into x minus 2. A 40 into 4 minus 2, 40 into 2, 80. Option B only correct. Either calculate A distance up to meeting point or calculate B distance up to meeting point. This question answer option D only correct. Next, third example number 3. Two stations A and B are 120 kilometers. One train starts from A at 7 am and travels towards B at 20 km per hour speed. Another train starts from B at 8 am and travels towards at 30 km per hour speed. At what time will the meet is dash? Here find out meeting time. A 9 am, B 10 am, C 10:30 am, D none of these. Here A towards B, B towards A. These two are moving opposite direction. Then relative speed, sum of their speeds. Here A to B distance 120 km. A starting time 9 am, B starting time 8 am. A next method, suppose A time up to meeting point. A time up to meeting point, consider X. Then B time up to meeting point, X minus 1. Because A starting time 7 am, B starting time 8 am. The time gap between A and B 1 hour. Therefore, B time is X minus 1. Here B time is 1 hour less than A time. The B time X minus 1. A next method, if the problem is belongs to opposite direction, A distance up to meeting point, B distance up to meeting point is equal to total distance 120. A distance up to meeting point, distance is equal to speed into time. A speed 20 km per hour. A time X hours. B distance is equal to B speed 30 km per hour. Time X minus 1 is equal to 120. Next 50x. 50x is equal to 150. X is equal to 3 hours. Suppose consider A meeting time after X hours they will meet. Find out meeting time. A starting time 7 am plus X hours. 7 plus 3, 10, 10 o'clock. So option A only correct. Option B 10 am only correct. Suppose if we consider B, meeting time X minus 1, B 8 o'clock plus X minus 1, where X is equal to 3. 3 minus 1, 2. 8 plus 2, 10 am. Option B only correct. Here first example, that is same direction logic. Second example, third example, opposite direction method. Here next example number 4. If A starts from X towards Y and B starts from Y towards X respectively, if reach their destinations in 4 hours and 6 hours respectively, when will they meet is dash. A 2 hours, B 2.4, C 3 hours, D 3.4 hours. Opposite direction means A distance up to meeting point plus B distance up to meeting point is equal to total distance. But this example, distance not given and speed conditions also not given. Using assumptions calculate meeting time. Here method, X towards Y, Y towards X. Here X towards Y distance is equal to Y towards X distance is equal to same. Consider D distance and find out X towards Y speed. X towards Y speed is equal to distance by time. X towards Y time duration only 4 hours. Therefore speed D by 4. And also calculate S to Y towards X speed, distance by time, with time 6 hours, D by 6. And X towards Y speed, Y towards X speed. Your next method, if the problem is belongs to opposite direction, then method A distance up to meeting point, then B distance up to meeting point is equal to total distance. A total distance is equal to D. A distance is equal to speed into time. A speed is equal to D by 4. Let A time up to meeting point X hours. Then time X hours. Then B meeting time also X hours because there is no time gap between A and B. Both starting time same. Then A time up to meeting point X hours. Then B time up to meeting point is also X hours because there is no time gap between A and B. Next B distance, a B speed D by X. B time X is equal to D. By using LHS and RHS, D term cancel. Next, x by 4 plus x by 6 is equal to 1. Here next, LCM 24. Numerator 6x plus 4x is equal to 1. Here 10x is equal to 24. X is equal to 2.4 hours, where x is nothing but meeting point of two persons. A 2.4 hours, option B only correct. This is about general procedure. A next shortcut method. This type of questions are given. Apply the short procedure. If the problem is belongs to opposite direction, T1 into T2 by T1 plus T2. Opposite direction concept only, time conditions only given. Then opposite direction T1 into T2 by T1 plus T2, where T1 is equal to 4, T2 is equal to 6, T1 into T2, 4 into 6, divisible by 4 plus 6, 24 by 10, 2.4 hours. Similarly, if the problem is belongs to same direction, then meeting time is equal to T1 into T2 by T2 minus T1. Same direction, denominator difference method. Opposite direction, addition method. Suppose same direction, find meeting time. 4 into 6 by 6 minus 4. 24 by 2, 12 hours. Meeting time of two persons, 12 hours. Is same direction, opposite direction. These two indicate shortcut method. This is about the general procedure. Then fourth example completed. Next, fifth example. If A starts from X towards Y at 10 a.m. and B starts from Y towards X at 11 a.m. if reach their destinations at 2 p.m. and 5 p.m. respectively, at what time will the meet is dash? A 11:40 a.m. B 11:48 a.m. C 12:40 p.m. D 12:48 p.m. Method. Same as previous example. A distance not given here. X towards Y distance is equal to Y towards X distance is equal to D. Then X towards Y speed is equal to distance by time. But A time 10 p.m. to 2 p.m. 10 p.m. to 2 p.m. 4 hours. 10 to 12 p.m. 4 hours. A speed D by 4. And S2 is equal to distance by time 11 a.m. to 5 p.m. 11 a.m. to 5 p.m. is equal to D by 6. A B takes time 6 hours. A takes time 4 hours. A D by 4, D by 6 respectively. A next point, let A time up to meeting point. Let A time up to meeting point X hours. Then B time up to meeting point X minus 1, because A starting time 10 a.m. B starting time 11 a.m. The time gap between A and B 1 hour. Here B takes 1 hour less than A time. Less than indicate X minus 1. But previous example, A and B starting time same. But this example, A starting time 10 o'clock. B starting time 11 o'clock. Time gap only 1 hour. Then B time X minus 1. Here next procedure. Here if the problem is belongs to opposite direction, A distance plus B distance is equal to total distance. A distance speed into time, a D by 4 into X plus D by 6 into X minus 1 is equal to D. Here comparing LHS and RHS, D term cancel. Here remaining X by 4 plus X minus 1 by 6 is equal to 1. Here next LCM 24. Numerator 6x plus 4x minus 4 by 24 is equal to 1. Here next 10x is equal to 28. X is equal to 2.8 hours. X 2.8 hours. Find meeting time. Suppose consider is equal to A. A starting time 10 o'clock. Next x hours. Meeting time of A up to meeting time of A x hours. A 10 plus x 2.8 is equal to 12.8. A 12.8 convert into a minutes. A 12 o'clock plus 0.8 convert into a minute multiplied by 60 is equal to 12:48 p.m. Option D only correct. Here next for fifth example method. But previous example A and B time same, starting time same, then apply the short procedure. A T1 into T2 by T1 plus T2. Here shortcut method not to applicable because A starting time 10 o'clock, B starting time 11 o'clock. That method is not applicable. Just you apply the general procedure. A distance up to meeting point plus B distance up to meeting point is equal to D. But X indicate meeting time of meeting time. A meeting time up to A time up to meeting point X hours. Then B meeting time up to meeting point X minus 1. Here X is equal to 2.8. Consider A 10 o'clock plus X hours. A 10 o'clock plus 2.8 12.8. But point consider only minute but not hour. 0.8 convert into a minute. A 0.8 hours convert into a minute multiplied by 60. Hour convert into a minute multiplied by 60. Minute convert into a hour divisible by 60. So answer 12:48 p.m. Suppose if we consider B, but B time up to meeting point X minus 1, but B starting time 11 o'clock, 11 plus 1.8 because X minus 1, 2.8 minus 1 and 1.8, 12.8, 0.8 convert into a minute multiplied by 60, that is 12:48 p.m. Option D only correct. Next, sixth example. A theft is reported to a policeman. The thief starts running and the policeman chases him. When the policeman starts chasing, the thief was at a distance of 250 meters. The distance gap between thief and policeman 250 meters. The thief and the policeman run at the speed of 8 km per hour and 9 km per hour respectively. Find the time the policeman will take to catch the thief. A 10 minutes, B 12 minutes, C 15 minutes, D 20 minutes. You find the time. Time is equal to distance by speed. Two speeds are given, then check the direction. Time is equal to meeting time, distance by relative speed. Distance between thief and policeman 250 meters. Relative speed. Thief and policeman are always moving only same direction. Relative speed, difference of their speeds. Difference of their speeds 9 minus 8 km per hour. A numerator meter, denominator kilometer per hour. Kilometer per hour convert into a meter per second multiplied by 5/18 is equal to 250 into 18 divisible by 5 is equal to 900 seconds. 900 seconds convert into a minute. Convert into a minute divisible by 60. Divisible by 60 is equal to 15 minutes. Option C only correct. Here important only conversion. Here kilometer per hour convert into a meter per second multiplied by 5/18. Next hour convert into a minute multiplied by 60. Next second convert into a minute divisible by 60. A total 900 seconds, but options indicate in terms of minute and point. Then second convert into a minute and point divisible by 60. 900 seconds convert into a minute. 900 by 60, 15 minutes. Option C only correct. In note, thief and policeman, the type of questions are given. Calculate only same direction application. A meeting time is equal to distance by difference of their speeds. Next, seventh example. The ratio between the speeds of two trains is 7:8. If the second train runs 400 kilometers in 4 hours, then the speed of the first train is dash. A 70 km per hour, B 75 km per hour, C 84 km per hour, D 87.5 km per hour. First statement. Suppose A speed is equal to 7x and B speed is equal to 8x. A speed is to B speed 7:8. Here A speed is to B speed 7:8. 7x and 8x respectively. If the second train runs 400 kilometers in 4 hours, second train speed, then B speed is equal to distance by time. A distance 400 time 4. A distance by time is equal to 100 km per hour. A B speed 100 km per hour. Where B speed 8x. 8x is equal to 100 km per hour. X is equal to 100 by 8 km per hour is equal to 4 into 25, 4 into 2. 25 by 2 km per hour, where x is equal to 25 by 2 km per hour. Find out speed of A. Speed of first train 7x. 7 into 25 by 2 km per hour is equal to 87.5 km per hour. Option D only correct. Seventh example method, option D only correct. Next, eighth example. Two trains running in opposite direction cross a man standing on the platform in 27 seconds and 17 seconds respectively. They cross each other in 23 seconds. The ratio of their speeds is dash. A 1:3, B 3:2, C 3:4, D none of these. D none of these. Right method. Suppose first train speed A, speed of A x meter per second, and speed of B y meter per second. Then A distance is equal to speed into time. Speed x time 27 seconds, and B distance speed into time, speed y time 17 seconds. Next, meeting time is equal to distance by relative speed. A meeting time is equal to 23 seconds. A distance, a train crosses another train, then distance is equal to sum of length of two length objects. A first train distance 27x, second train distance 17y, divisible by relative speed x plus y. A speed x meter per second, B speed y meter per second, relative speed, sum of their speeds. Next, 23x plus 23y is equal to 27x plus 17y. Next, 4x is equal to 6y. A 4x is equal to 6y. X by y is equal to 6 by 4. 6 by 4, 3 by 2. 3 is to 2. X is to y, 3 is to 2. Option B only correct. Here important only assumptions. A speed not given, A distance not given, B speed not given, B distance also not given. Using assumptions, calculate A distance and B distance. Note, a train crosses a single object. The distance is equal to length of the train. A train crosses a stationary object. The distance is equal to sum of two length objects. A d is equal to length of the train when single object. Distance is equal to length of the first train plus length of the second train when stationary object. A meeting time distance by relative speed. Here calculate x by y or x is to y or x is equal to y. 3 is equal to 2, 3 by 2, 3 is to 2. Option B only correct. Last example. If the distance traveled s in meters by a particle in time in seconds is given by the formula s of t is equal to 4 plus 3 of t plus 2 of t square plus t cube. Then what is the distance traveled by the particle in the fifth second? Here calculate up to 5th second. Up to 5th second. Here find out s of t. S of t is equal to 4 plus 3t. Next 2 into t square. Next t cube. Now substitute s of 5 and t is equal to 5 seconds. Here 4 plus 3 into t 15. Next 2 into 25. T cube 125 is equal to 194 meters. Option D only correct. This is up to 5th second. Suppose the gap between S4 and S5 and calculate S4 where T is equal to 4. 4 plus 3 into 4 12 plus 2 into T square 16. T cube 64. S of 4. Next similarly S of 5. This is 194. The time gap, the distance gap between S4 and S5 that is in the 5th second. Up to the 5th second 194. Suppose calculate only 5th second gap. The gap between 4th second and 5th second. 4th second and 5th second. S4 is equal to 4 plus 12 16. 16 plus 32 48. 48 plus 64. Here 48 plus 64. Here 112. 112. Next the gap between S4 and S12 194. Next 112 and 82 only correct. In the 5th second 82 meters. Up to 5th second 194 meters. You check the problem. In the 5th second means the gap between S4 and S5 82. 82. Suppose calculate up to 5th second distance 194 meters. This question depends on the problem statement. Calculate total distance 194. The gap between 4th and 5th only 82 meters. But this question answer B 82 meters only correct. If total is given 194. This is about 9th example solution. A relative speed concept completed. This topic depending only one principle. Relative speed. Relative speed only two applications only exist. One is same direction and another one is opposite direction. Same direction difference, opposite direction addition. Next notations. Here a train crosses a single object. D is equal to length of the train. A train crosses a stationary object. D is equal to length of the train plus length of the tunnel or platform or another train. Next conversion. Meter per second or kilometer per hour. And time also convert into seconds or convert into a minute. These all are important to relative speed concept. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.